I think you'll find this, if you just follow along on this practice and you take care of business here, you should do fine, okay? Every problem is very similar. Number one, tomorrow will be exactly like this. Max and min, state the domain and range. So how do we find that max and min thing? Right, well, first we're gonna need to find the axis of symmetry. Axis of symmetry is x equals negative b over 2a. So our b is negative 2, so it's going to be 2, positive 2. And then we're 1 times 2, so that's going to be also 2. So our axis of symmetry is equal to 1. Now, that's going to help us with our vertex. So our vertex is 1. And then we got to find the y value by plugging back in there. So it's going to be 1 squared minus 2 times 1 minus 6. So I'm looking at negative 7, I think. And of course, this is a happy parabola. It opens up because it's positive. So it's going to be a minimum equaling negative 7. My domain, x, such that x equals all the reals. And my range, y, such that y is going to be what? Well, it is open up, so it's going to have to be greater than or equal to my y value at the vertex, negative 7. Questions on number 1 there? Section 5.2, we did that earlier in the year. Earlier in this chapter, shall we say. All right, number 2, solve by factoring. Let's put it in standard form to start with. Or shall we say set it equal to 0. That'd be 5x squared, bringing it to 30. It's going to be minus 30x, and then it's going to be plus 45 equals 0. As I see that, I'm going to take a GCF out. So 5 is going to come out. X squared minus 6x plus 9 still equal to 0. Oh, that looks pretty good. In fact, it's a perfect square trinomial. X squared minus 6x plus 9 is perfect square trinomial. But b factors of 9 that have a different add up to be 6 would be 3. So this does factor to 5. And it is x minus 3 and x minus 3. It's not asking you to solve, it's just saying factor, so that's where you're going to leave that. You don't have to put that equal to anything. Questions there? Again, if you just pay attention halfway in this part today, you should at least be able to get half of them. You know what I mean? Don't even have to write anything down, you just kind of watch a little bit. Probably be helpful. All right. We've already done this a couple times too. X equals 6. And in fact, all these questions are right from the quizzes that we have taken, so should feel a little bit familiar. Now, common mistake is you forget to take this over, you'll get the sign will be wrong, so that's going to be minus. Bring this over, it's going to be plus. Okay, and now we're ready to FOIL. X times x, x squared, that's going to be plus 8x. It's going to give me minus 6x. And then I'm going to get minus 48. So just got to combine the middle terms. X squared, so it's going to be plus 2x minus 48 equals 0. And there you have number 3. So make sure you move those to the other side, so you get the signs proper. Because if you don't, have a little problem there, you won't get the signs right, so, and then I'll take a little bit off of that. All right, number 4, always every year, number 4 messes people up because I try to make it easy. My friends, that's already a perfect square trinomial right here. It's already ready for you to do complete the square. So make a note to yourself, number 4 is ready to complete the square. I'm gonna be that way tomorrow too. Everybody tries taking the 25 over and then it gets all messed up. You can do it. You just subtract 25, then you're gonna add 25 to both sides. It just goes out anyways. So you can still do it, but it's all ready to go. That's perfect square trinomial. X minus 5 squared equals 54. How many times have we completed a square? At least 50. Okay, take square root of both sides now. Okay, x minus 5 equals plus or minus square root of 54 is 9 times 6. That 9 is going to come out. We're going to end up with 3 square roots of 6. Take the 5 over. Becomes positive 5 over here. Plus or minus 3 square roots of 6. Note to self, number 4 already is ready to do complete the square. Already perfect square trinomial. Everybody good there? Questions or concerns there? Number 5 gets messed up also because everybody wants to try to complete the square or do something that you don't need to do. What I'm meaning there is that you do not need to do anything to number 5 other than to get x squared by itself. We're missing the middle term here, aren't we? Okay? So we're gonna have 2x squared. Take the 18 to the other side, it's gonna become negative 18. Divide by 2, you're gonna have x squared equals negative 9. Don't make this one hard because it's not, is it? Missing the middle b term, missing b in the quadratic. You just solve for x squared, take square root of both sides. Of course, we know what negative 9, square root of negative 9 is going to be plus and minus 3i. How are we feeling there? Everybody okay? Questions on that guy? Good thing about 6 is that we're not going to do it, so don't worry about that. It'll be a give me tomorrow. Find the zeros. Now, what's that mean? What does that mean? Well, you could use completing the square, you could use the quadratic, or you could factor. Okay? So it doesn't matter to me, whichever one you want. Factoring won't work because there's no factors of 18 that can add up to be 6. So that leaves me with quadratic and completing a square. Now, as I look at this problem, I'm thinking middle term is 6. I think I can complete the square probably pretty easy on this one. There's nothing in front of the x squared, so I like completing the square. So that's how I'm going to go about it. So we have x squared plus 6x. Taking that 18 to the other side, if I set this equal to 0, taking the 18 out is going to be negative 18 over here, isn't it? All right, as we know, half the middle is 6. Squaring would be, or half the middle is 6. Or 6 is the middle, half would be 3. Squaring would be 9, so we're going to add 9 to both sides. Lo and behold, what have I created? Perfect square trinomial. That's actually the third one we've seen so far in the review, isn't it? Okay. Always x. Always whatever the sign is, always half the middle. Squared. All right, what am I getting over here? None other than negative 9. Ready to take square root of both sides. So I'm going to end up with x plus 3 equals the square root of negative 9, which is plus and minus 3i. Take the 3 over. You're going to come negative 3 plus or minus 3i. Remember that's complex conjugate? It'll be 1. There's 1, there's another. 1's plus, 1's minus. And there you have it. Down through 7. How we doing, folks? All right? Hopefully you dug in and tried some of these ahead of time. It's always good to try to do a few ahead and see where you get stuck. But if you're not, at least be copying some stuff down now to be able to submit if you haven't done so. Complex conjugate. Don't mess this one because remember, we need to have them in the form A plus BI. Well, that's not, is it? So make sure you put the real part first. So this is going to be 4 plus 3i. Some might call that kind of like standard form. Okay, you gotta put the real part first. We've talked about that over and over and over and over. So its conjugate then is going to be 4 minus 3i. Number 9, I did specify once you use a quadratic, and that's probably good because I wouldn't want to do complete the square for that one, would you? No, there's a lot going on there. We got 4 in front of the x squared. We got negative middle. You're going to get a lot of fractions, okay? So don't forget negative b plus or minus the square root b squared minus 4ac all over 2a. All right, so let's find b squared minus 4ac. So b is negative 1. So negative 1 squared minus 4 times a. My a is 4. And my c is 5. All I'm trying to find is b squared minus 4ac. Negative 1 times negative 1 is going to be positive 1. So I'm going to have positive 1. It looks like positive 1 minus 80. So it looks like I'm going to get negative 79 underneath there. All right, so we're ready to fill out the rest of it. Okay. So negative b is going to be 1 because negative, because b is negative 1. Plus or minus the square root of negative 79 over 2 times a. A is 4. 2 times 4 gives me 8. There's just a little bit I can do with this one. Negative can come out from the radical, but 79, nothing going on there. So this guy ends up being 1 plus or minus I. We got to take that out because it's like simplifying. Over 8. Nothing else going on there. So again, we'll use a quadratic. Make sure we get b squared minus 4ac correct, okay? B squared minus 4ac. Ended up being negative. So that's where we got that I involved there. All right. Moving on to the multiplication part of the Chapter 5, I think this should be pretty straight up for most of us. Make sure you put, here we are, sticking at us again, standard form. Let's go ahead and distribute 6i times 4, 24i. 6i times negative 6 would be positive 36i squared. Whoops, that's not positive, that's negative, my bad. 6i times negative 6i gives me negative 36i squared. Got to get the square up there. Of course, we know I squared is negative 1, so negative 1 and negative 36 gives me positive 36. That's my real part. I'm going to put that first, just like it's saying right here. My complex part is going to be plus 24i. Please make sure you put the real part first tomorrow. Okay. Everybody okay? All righty. Getting closer to the one we're looking for. All right, simplify. I to the 20. We got to figure out what I to the 20. Remember, what's the closest factor under 20 that a factor of 4? Well, 4, 8, 12, 6, 20. 20 is a factor of 4. So really, I to the 20th is Positive 1, isn't it? So positive 1 times 8, negative 8 is going to give us negative 8. Remember, I to the first is I to the second, negative 1, I to the third, negative I, and there you have what we just found. I rolls around to the fourth, multiples of 4, every one of them will be 1. Feeling okay there? All right. Maybe the most time-consuming problem is 12. I wouldn't call it the hardest problem. I just said time-consuming because we need to multiply by the complex conjugate. Is the real part first there? Yes, it is. So 5 minus 3i, 5 minus 3i. So now we got some FOILing to go. All right, negative 2 times 5 gives me negative 10. Negative 2 times negative 3 would give me positive 6i. 2i times 5 would be positive 10i. 2i times negative 3i gives me negative 6i squared. On the bottom, 5 times 5 is 25. Remember, when we have the complex conjugates, what's going to happen to those middle terms? They are going to cancel. So I'm not going to put those out. That would be minus 15i, and that'd be plus 15i would be the middle terms. They cancel. So the end term is going to end up being negative 9i squared. So those middles canceled. I just didn't write them out. All right, now we're ready to simplify anything we can. We got some stuff to take care of here. What's this guy become right here? That becomes positive 6, doesn't it? Okay, so we got positive 6 and negative 10, which would give me negative 4. Add those up, we're going to get plus 16i, 6 and 10. This is going to become positive 9. So I think we're going to get 34 under there. How's that looking, everybody? One more step, because we have some commonality, don't we? 4, 16, and 34 all can be division by 2. So we really end up with negative 2 plus 8i over 17. Hopefully this is helpful for you. How are we doing? Is it helpful? I'm glad to hear that. Hopefully it'll pay off tomorrow with a good assessment. 13. It seems like students don't know what to do with 13. Okay? All I want you to do here is FOIL. 3 minus 2i times 3 minus 2i. Okay? 3 times 3 is going to give us 9. That's going to give me minus 6i. I'm going to get another minus 6i. And then I'm going to get a positive 4i squared. Negative 2 times negative 2. Okay, positive 4i squared really becomes negative 4. So 9 and negative 4 will give me 5. Minus 12i, negative 6, and negative 6. Still okay, my friends? Everybody there? All right, guess what? We're at the one we've been looking for. That's the last one for today. So here we go. Consider this function, see what's going on with it. We got to go through some stuff, graph it, open up. Part A, up or down? He opens up. He's a positive guy, isn't he? Because 3 is positive. Axis of symmetry. X equals negative b over 2a. Let's see, what is my b? Looking like b is negative 12, right? So we're looking at negative, negative, so it's gonna be positive, and then A is 3, and it's gonna be over 6. Looks like my axis of symmetry is 2. We can start to sketch our graph if we like. And we'll do our axis of symmetry, we'll make it purple today. X equals 2. All right, finding our vertex. We already know that the x value is 2. Plug 2 back into there. 2 times 2 would be 4. Times 3 would be, that was a 2. Am I plugging 2 back? Did I do something wrong? I feel like I did something wrong. B. I think I'm all right. Am I all right? Okay. All right, 2 squared would be 4, right? 4 times 3 gives me 12. They're positive. And then minus 24, minus 6. So it looks like, is it 18? Negative 18? That sound right? All right. It's gone there a ways, isn't it? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So suspect down there, intercept 6, 1, 2, 3, 4, 5, somewhere in here. This guy's coming down. You know. So label that point, of course, 0. Negative 6 is your intercept. Vertex, 2, negative 18. There's your graph, and you might want to say A, B, C, and D. D is 0 here, 0 and negative 6, that's your intercept. Intercept or y-intercept. And then your graph, of course, as we did our letters, was E. And there's a ace. You ace the test, chapter 5. Kind of touches just about everything, doesn't it? We get max, min, domain, range. There's a little part we didn't get. That's where we did the determinant, b squared minus 4ac, figured out if there was 2 solutions, 1 solution, and no solution, but that's okay. Positive solution. Any questions? Fantastic. Thanks for paying attention. Submit if you haven't done so.